Hey everyone, thanks for your time. For your consideration, this video is part 2 of a recent phone interview I did with a NASA Exploration Ground Systems Operation Manager. The Artemis II Orion is nearly complete. The solar array wings are going on right now, and in a few weeks the spacecraft will be handed over to EGS for launch processing. Kind of like with other payloads where launch processing means you fuel it, encapsulate it in a launch fairing, and then take it out to the rocket and put it on top, that's what EGS will be doing with Orion. Except that this is a spacecraft that will be flying by the moon on this flight and then orbiting it on the next one with a crew of 4 astronauts. So there's a lot more to fueling it and a lot more to encapsulating it, and those are the rabbit holes that I wanted to dig into in this interview. In late February, I interviewed Marcos Pena, who is NASA Operations Manager for Exploration Ground Systems Spacecraft Offline Operations. As the name implies, EGS Spacecraft Offline Operations processes elements of Orion and SLS at Kennedy Space Center in locations away from Launch Complex 39 and the Vehicle Assembly Building, where EGS Integrated Operations puts together the whole vehicle on the mobile launcher. Right now, the Artemis II Orion is in the Industrial Operations Zone of the Neil Armstrong Operations and Checkout Building at KSC, where prime contractor Lockheed Martin is finishing assembly and test of this first fully crew-outfitted and crew-rated unit. What I interviewed Mr. Pena about, primarily, was the work his team will do on Orion after they receive the spacecraft from Lockheed once assembly and test is complete. For Artemis II, Orion is the critical path to launch readiness, which is officially no later than April 2026. Shortly after the spacecraft is handed over to EGS, they will move Orion from the O&C building to the Multi-Payload Processing Facility, or MPPF. In part 1, I asked Mr. Pena about preparations for the work that Spacecraft Offline Operations does and other flight hardware launch processing they will be doing, such as hydrazine servicing of the SLS in-space second stage, the interim cryogenic propulsion stage, or ICPS. A little later in this video, I'll get to the other SLS hardware they will receive and get ready for stacking in the VAB. Here, let's recap the main part of the MPPF work for the Orion spacecraft, which is several weeks of loading most of the flight commodities onboard the crew and service modules. I asked Mr. Pena about the loading sequence for the different fluids, from bipropellants to cabin atmosphere gases. The expected sequence of commodity loading and work in the MPPF, and so now we have, the service module has a full complement of consumable tanks, and it's fully crew rated. Can you talk about the planned sequence of commodity loading and how what additional things you have to load on the spacecraft because it's now fully crewed?
Copy that. Yeah, so I tell you, I don't have the actual full schedule in front of me right now. Otherwise, I would have cheated and gone and looked directly at it. But I could give you just a general sense. So for the servicing between Artemis I and Artemis II, is largely the same. We used a multi-payload processing facility to do hazardous processing. So this is where we're going to load all the hypergulls. We are currently, I believe, we're planning to do the SM hypers first. SM, as you may be aware, is a biprop system. So we have to do the nitrogen tetroxide and the MMH, monomethyl hydrazine, on the SM. We do the SM up front because we have a requirement to monitor it for 25 to 30 days to ensure that the vehicle's plumbing is tight. So that's the way that we optimize the flow. We do SM, MMH, and nitrogen tetroxide. I'm not sure exactly which one's first, but those are back to back. Then we have to do CM. The CM has a monoprop system which uses hydrazine, so we do that as well. And then you get into your non-hazardous, non-hypergolic commodities. So in the MPPF, we'll also be loading GN2 on the service module, which is needed for the mission, and everything that I said so far is common with Artemis I. We'll also be loading ammonia into the vehicle. So ammonia, hypergols, GN2, those are all things that we serviced during Artemis I, and we'll essentially be doing those procedures the same way as Artemis I, with some enhancements that we're capturing in the procedures and to some of our ground support equipment. Where we get into new work for this crew-rated vehicle, we're looking at adding oxygen. We will be performing O2 servicing on the SM and on the CM at the MPPF. That's the main new commodity that we're adding at the MPPF. However, we will also be loading liquid cooling garment fluid. It's used the short-term LCG. We'll be loading that fluid in the MPPF as well. After we've loaded all the other commodities, we'll load the LCG fluid, and that is to support crew testing that we're going to do in the MPPF, which I'm sure you'll want to talk about. But yeah, so after all the commodities are loaded, we'll do LCG loading, and then we'll be ready to perform some testing with our Artemis II crew.
After the interview via NASA KSC Public Affairs, he provided this list of the commodities in their tentative order of loading in the MPPF. The sequence can be modified if necessary to optimize the workflow and minimize the amount of time needed to complete it. First are the two hypergolic bipropellants used by the European service module engines, showing the oxidizer, nitrogen tetroxide first, followed by monomethylhydrazine. Those are loaded in two pairs of large tanks in the ESM. We can see the tops of the four of them in this image taken of the Flight Model 2 unit when it was being packaged for shipment in October 2021 from prime contractor Airbus's facility in Bremen, Germany. Here is an Airbus graphic labeling those different storage tanks. Next on the list are the cabin atmosphere gases for the crew compartment, gaseous oxygen supplies in both modules, and gaseous nitrogen in the service module. We can see those four overwrap pressure vessels on the outside edge of the top of the ESM. Those are part of the consumable storage system, or CSS. Hidden out of view are the water tanks for the crew. However, in this shot of ESM-3 going back a year or more while it was still in assembly, we can see one set of those water tanks on the right with one of the four propellant tanks on the left. As was covered in the Part 1 video, the water tanks will be serviced after Orion is stacked in the VAB, much closer to launch. Next, the crew module ammonia system will be serviced. That is a part of Orion's thermal control system. Following that, the crew module reaction control system hydrazine is loaded. The crew module operates on its own between separation from the service module before re-entry, and it has to maintain attitude and fly a re-entry profile to a splashdown target. The RCS thrusters use this version of hydrazine as a monopropellant. The propellants in the service module and the crew module are pressure-fed, with both using gaseous helium for pressurization. The CM helium is loaded and serviced next in the MPPF. However, the service module helium was already loaded earlier during assembly and test in the ONC building. Last on the list is the liquid cooling garment fluid that helps keep the flight crew comfortable while they are wearing their launch and entry suits. With outfitting and assembly of Orion systems and equipment nearing completion, a natural question at this point in the pre-launch timeline is when the spacecraft will be outfitted for familiarization by the flight crew. Orion can operate autonomously and can be remotely commanded and controlled, but the Artemis II build of the spacecraft is the first that is fully crew-rated, and it is also designed to be flown by astronauts. Some onboard equipment won't be installed until just before launch, but when spacecraft offline operations takes over control of the vehicle for launch processing, there's the question about when the crew would quote-unquote kick the tires of their spacecraft. During the space shuttle days at KSC, flight crews would visit the orbiters near the end of their turnaround from the last flight to the next. The Crew Equipment Interface Test, or CEIT, was one of the indications that the orbiter was almost ready for rollover from the Orbiter Processing Facility, or OPF, for stacking. So that is how I flavored my question to Mr. Pena about the crew testing that is planned at the end of the work period in the MPPF. I know, back in the shuttle days, the flight crews would usually go to the to the OPF when the orbiters were still horizontal and do a crew equipment interface test. Is there some part of that there, and kind of how you were talking about the testing? Is this going to be like a suited testing, unsuited testing, and how much will the crew module be outfitted for this test or testing?
Yeah, sure. Okay. After we're done with all of our commodity loading, we have some time allocated, probably like a week and a half, to do all these crew-related tests. We have two major tests that we're doing. The first one is actually what you mentioned, that was done during shuttle, CEIT, Crew Equipment Interface Test. That testing, the vehicle is going to be outfitted as close to launch date as possible. There may be some engineering simulators or like 3D printed volume representative simulators if an item's not ready. Say, for example, we're installing the fire extinguisher or the exercise device. In most cases, we are going to have the actual item in there. But in some cases, there are time-sensitive stuff that we're not going to load it that early into the MPPF. And some of the things that we outfit, if we can leave it in the vehicle configured, we will. But in general, the goal is to outfit the capsule with as close to a launch day configuration as possible. Then the crew are going to go inside the crew module, and we'll have some of our closeout crew teammates there, help them get strapped in. And this is all, the CIT test is all occurring in shirt sleeve. And they'll have a checklist that they're going to go through, and basically a lot of it is reach assessments and figuring out, dialing in how we want to adjust each individual crew seat. The settings for Christina Cote is going to be very different than Jeremy Hansen. So those are the kind of things that we are going to be walking through. And that is one of the major tests that we'll be doing after all the commodities are loaded. After that, we are doing what we call a suited crew test. So we are going to, as I mentioned, one of the last things we're going to load is liquid cooling garment, but we're going to have the crew, or it could potentially be a backup, but we're going to have crew members dress out in their suits, whether it's their day of launch suits or engineering suits. That is forthcoming to be nailed down. But they're going to suit up. They're going to go inside the crew module, and we are going to connect their suits to the umbilicals that would supply this liquid coolant garment fluid. And we are going to do leak checks. And so our closeout crew are going to do leak checks. There's also some leak checks that I believe the crew members are going to do themselves. And that is a major test that we want to get through the MPPF, because the next thing that we do is we go to the last and if we encounter any issues with those leak checks from that suited crew test, it gives us time to work through those issues before we put the crew again in the crew module in their suits for the CDDT at the VAB, countdown demonstration test. So the concept is finding issues earlier in the flow as we can before we go to the VAB, and we're on the clock.
The spacecraft will be powered up for much of the time it is in the MPPF, and in addition to the environmental control and life support systems that are flying for the first time, the crew systems are also new. That includes displays and switch panels, hand controllers, and cursor controllers. Presumably those will be installed and functional for some or all of these crew interface tests. The crew seats will be installed as a part of these tests to help make seat adjustments for each of the crew members. As he noted at the end there, a higher fidelity countdown demonstration test, CDDT, is planned to be performed after the vehicle is fully stacked and connected in the VAB. After all the commodities are loaded and flight crew testing in the crew compartment is completed, EGS will transfer Orion from the MPPF to the LASF, the Launch Abort System Facility, formerly the Canister Rotation Facility in the shuttle era. The general outline of work in the LASF is the same with Artemis II as it was for Artemis I. Spacecraft offline operations will stack the Launch Abort System tower on top of the crew module and integrate the LAS elements with the crew module systems. That includes test and checkout between those computers and the continuity between them. The LAS itself is different this time, and that's one of the differences that Mr. Pena noted between the workflow for Artemis I versus Artemis II. After the LAS is stacked, then the crew module is encapsulated for launch inside a 4-piece ogive-shaped fairing. In terms of the work in the LASF, is that pretty much, are there any differences or any major differences between, between the Artemis I and the Artemis II? I know the LAS is different, but in terms of, stacking the tower, installing the ogives, is the work in there on the spacecraft different or pretty much the same?
As you know, this is a full-up LAS that has all three motors. So with having all three motors active for this mission, because we're flying crew, of course, there's some additional testing that we do to check out that abort motor. The work is very, very similar to Artemis I. Some additional checks for that abort motor.
In an abort, the Orion flight control system will fly the launch abort vehicle, the crew module and the LAS, away from everything else, the SLS and the service module. The attitude control motor controller gets its steering commands from the Orion's vehicle management computers, and since this is Orion's first crewed mission, there's an all-up live launch abort system this time. This is the second all-up LAS. The first flew on the Assen Abort 2 test in 2019. Prior to that, 2 earlier generation units flew on Exploration Flight Test 1 and Artemis I, but those only had a live jettison motor to pull the LAS away from the crew module, which occurs for every launch. Mr. Pena also went into the weeds, which is what we want for this podcast, about a change to the concept of operations, or CONOP, for stacking the LAS on the crew module. They are looking at how to streamline operations beginning with Artemis III, and they found something that they are going to go ahead and start doing now for Artemis II launch preps.
We did change the CONOP of how we made the LAS to the CSM. As you know, with Artemis III, we'll have a docking module for our surface mission and docking with HLS. And that docking module leads to, as we were looking at that, working with our Orion and Lockheed team, we found that it is more efficient, CONOPS-wise, to install part of what it's called the LAS, the Launch Abort System MATA, Motor Adapter Truss Assembly, the truss that connects the LAS to the CSM. There's some feet on that truss assembly that has a pyro connection between the CSM and the LAS, and those feet, we call it the MATA feet, are normally you do that installation at the LASF, and it has super bolts at each of the 6 locations, and those super bolts have pyros in them. So anyway, we found that for Artemis II and beyond, it's more efficient to install those MATA feet in the ONC. So for Artemis III, the docking module will be installed. We would install the forward bay cover will be installed in ONC, and then these MATA feet will get installed. So we decided that actually makes our schedule more efficient in the last if. So we actually pulled some time out of the schedule and moved some of that work to the ONC for starting with Artemis II. So anyway, there's a CONOP change that we had to do starting with Artemis III, but we went ahead and took advantage starting with this flow where we're going to do that those feet installation in the ONC. So when the CSM arrives at the LASIF after it's been fueled in MPPF, we actually have a simpler connection to make between the LAS and the CSM. We are going to be mating to those feet that would have already been installed in the ONC, and that's just almost like a pinned connection at 12 locations, 2 trusses for each of the 6 feet. And that pin connection is much more simpler than the Super Bowl pyro connection that we would have otherwise had to perform. So once you got that, that's the major difference in our CONOP.
This is a shot of a MATA, not the Artemis II MATA, with the adapter cone at the top and the truss assembly below it. There are 6 retention and release mechanisms that connect the truss legs with the crew module structure. You can see in these pictures of the Artemis I Orion during final closeouts in the ONC building in late 2020 where those legs are bolted in. The forward bay cover fits around those 6 MATA legs on the LAS. Those attach points have pyrotechnic devices to separate the truss from the crew module simultaneously with the jettison motor firing. That's where EGS and Orion and Lockheed Martin moved insulation of the MATA feet. Those will now be installed where these images were taken, the fast cell in the ONC building. As noted, given the extra time due to the slips of the Artemis II launch processing flow, EGS moved this work up even though it's not necessarily required until Artemis III. Beginning with that mission, NASA docking system hardware will be installed on top of the forward bay cover. The MATA truss assembly still fits over the top of both the forward bay cover and the docking mechanism. And, as Mr. Pena noted, moving this work up in the sequence will help with the workflow in the LASIF, the Launch Abort System Facility, given the desire to optimize this Artemis II flow and reach launch readiness as soon as possible. He then continued with an overview of the encapsulation of the crew module with the ogive fairing panels and lessons learned from the Artemis I flow in the LASIF.
Once you make the LAS, you're doing the ogives exactly the same way as Artemis I. We are implementing several lessons learned with respect to ogive installation. We have some new alignment tools. We also have some new engineered scaffolding that is going to allow us to get access to the vehicle much more quickly versus bringing the vehicle into the LASIF and erecting the scaffolding around the vehicle. Now that's going to be largely already set, and we can drive the K-Mag under the scaffolding and pull the K-Mag out. So we have some improvements that we're implementing for this Artemis II flow that are all in the direction of more efficient and reducing the overall schedule.
Once that launch abort system integration work is completed and the fairing has been closed out for launch, such as with application of weather seals, the Orion launch assembly will be prepared for the move from the LASIF to the vehicle assembly building for stacking on top of SLS. The SLS program is the provider of the connector between Orion and the launch vehicle. For the Block 1 version of the vehicle with the ICPS, an Orion stage adapter connects the 5.5 meter wide Orion base with the 5.1 meter wide ICPS. In addition to servicing the hydrazine attitude control system tanks on the ICPS, EGS Spacecraft Offline Operations is also responsible for final launch preparations of the OSA after that hardware is delivered to Kennedy Space Center. There are also a few secondary CubeSat payloads for Artemis II, which will stay with the ICPS, OSA, and spacecraft adapter cone after Orion separates on Flight Day 1. I asked about where that processing will take place because there isn't as much room in the Space Systems Processing Facility, or SSPF, which was undersubscribed at the time of Artemis I, but now has both ISS and SLS production work taking place there. So the question is about the Orion stage adapter and just, I don't know if you have the room in I don't know whether it was processed in the SSPF last time for Artemis I, but what's the plan for the OSA, and do you guys have a new delivery date for the OSA, and then obviously what you're going to do with it once it arrives at Kennedy?
Copy that. I can answer that. So the OSA, as you pointed out, that was processed through the SSPF. SSPF is very busy these days, which is a good thing. They're working with Sierra Space on their Dream Chaser. There's ISS work that's going through there, in addition to core stage engine section sub-assembly that's occurring in there. So it's getting pretty full in there. So we looked at other possible locations where we can process OSA and install the secondary payloads. And we determined that the best location to do that is actually in the VAB. So the OSA is going to be arriving in a couple months. Yeah, so it's only it's looking like the April timeframe, and then with the payloads starting to arrive in June. And our plan is to do that in the VAB in a small lab kind of shop that's called the EDO, the Engineering Development and Operations Lab. So it's near the south side of the VAB, alongside the transfer aisle. So it's got a crane capability, and it's generally cleaned. So we're going to be using that space to process this OSA, and with and that's also where we're going to be installing the secondary payloads.
So, recapping the takeaways from the interview with Mr. Pena, the first Artemis II hardware EGS spacecraft offline operations will receive is the SLS ICPS, which will be brought over the NASA Causeway from United Launch Alliance's Delta Operations Center on the Cape Canaveral side to the MPPF in the KSC industrial area. EGS will load hydrazine on the stage's attitude control system tanks and then move ICPS to the VAB closer to when it is needed for stacking, which was expected in the April timeframe. The main bulk of their work will be processing and preparing the Artemis II Orion for stacking in the VAB. EGS is expecting to receive the spacecraft in late April and is forecasting 5 months of work in the MPPF and the LASIF, which would put a move to the VAB in the late September, early October timeframe. The work in the MPPF includes almost all the commodity loading, including hypergolic propellants and fluids for cabin atmosphere and pressurizing those propellant tanks. After those are loaded, the Artemis II flight crew will get in their spacecraft while it is in the MPPF to help visualize the layout inside the flight vehicle crew compartment that they will live in during the mission. Then Orion will be moved to the LASIF for the launch abort system to be stacked on top of Orion in that facility. That 2 months or so of work will include bolting the LAS motor tower on top, integration and checkout testing between the LAS and Orion, and then encapsulation of the crew module for launch. After closeouts, Orion would be ready for stacking in the VAB. EGS Spacecraft Offline Operations has been working since the last flow for Artemis I in 2021 on upgrading equipment and procedures, and they have also updated the sequence of operations that will be used going beyond Artemis II. The launch readiness timeframe for Artemis II could depend on how all this work goes in the spring and summer this year. Before Orion is stacked on SLS, EGS will also prepare the Orion stage adapter connector that goes between the spacecraft and the launch vehicle. A lab room in the VAB will be used to install the secondary CubeSat payloads in dispensers in the OSA. Those small payloads will be deployed after Orion separation and after the proximity operations demonstration that follows on Flight Day 1 of the mission. The OSA will be stacked on top of ICPS later this year, and that will be one of the signs that Orion stacking is getting close. Thanks as always for watching. Click on the like button if you found this video informative, and consider subscribing to find out what's going on with Artemis every week.